It's recording now. Okay. No, you do not need to copy all of this. Normally, because I print it out for you, so then you just fill in the spaces. I'll give you the notes next session, so then you can fill out based on one note. But here, let's have a look at some key ideas. So in your notes, what I do want you to write is this equation. Y equals ax squared plus bx plus c. On the side, just write general equation. So like your linear had a general linear equation. Out of curiosity, what was the general linear equation again? Anyone remember? Hands up. Hands up. Una? Yeah, ax plus c. Usually we call it mx plus c. But regardless, whether it's a, m, they're all parameters. Traditionally, we say y equals mx plus c. That's the general equation. General equation for a linear. Then for quadratics, it is ax squared plus bx plus c. So this means no matter what these parameters are, a, b, and c, if you just replace it with any number you like, whether it's negative, fraction, surd, if you keep it in a, so a coefficient of x squared plus a coefficient of x, and then a constant term, you will get a parabolic shape. That's why it's called the general equation. But there is also another form that you learnt early in this term, or even start of last term, end of last term, was the y equals ax, a bracket x plus h squared plus k. Anyone remember the name of this form where I got you to read up, down, left, right, then wide? What was it called? Turning point form. So this one, you write the second part, so you had the general form. Then I want you to write this second equation here, and then write on the side in brackets, turning point form. There are two main forms that you'll have to be familiar with. You have to learn how to go between either forms, which is the next exercise. The next exercise uses completing the square, which is a technique you guys haven't learnt, but this is, thanks team, exercise 5F, which is what we're doing next, to then bring from a general form to a turning point form. Okay? And obviously, if you expand the brackets, you go back to general form. So to factorize by completing the square, that's 5F, which you'll learn next lesson, you will be able to turn a general form into a turning point form. Okay? And then if you want to go from turning point form back to general form, you expand the brackets, which is what you learned in exercise 5A. You'll learn how to then bring it back. Okay? But there are two key forms for you to work with quadratics. The turning point form is best for sketching because you can actually read the graph up, down, left, right, thin, wide. Hence why it's called a turning point form, because you can determine what the determinant point is. Whereas the general form, what is beneficial? You can tell what the y-intercept is, because the y-intercept occurs when the x-coordinate is 0, but if you sub x equals 0 into the equation, these two terms will cancel out, and you end up with C. That's why C is known as the y-intercept for the general form. So I use both. So when I see a general form, the first information I get out of it is I see y-intercept, and then I use completing the square, and I find out the turning point. So I get 2 out of 3 key features. The next skill, which is the most important skill, is to find the x-intercept, which you guys did last session. So last session, you let it equal to 0, you learn to factorize. The whole skill there is to find x-intercepts. Okay, so y-intercept is easiest to find. Turning point's the next step, learning how to complete the square. And then we're going to tie it all together with x-intercept to then sketch the graph. Okay? Now, let's fill in the next couple of points. So usually, you need the turning point, and it can be found by two ways. You don't need to write this, I'm just filling it in. You can find the turning point of a parabola through two ways. See, a turning point happens to also be where the axis of symmetry is, right? So it means if you can find the x-intercepts, right? Once you find the x-intercepts, x1, x2, then the middle between the x-intercepts is where the axis of symmetry is. True? So the axis of symmetry, where it cuts the parabola in half, must be the center of your two x-intercepts. So how do you find the turning point? You just need an x and a y coordinate. You can find that x coordinate by finding the middle. So this is what I want you to copy down. To find turning point. So right on the side right. To find turning point. There are two ways. Method 1. Find x-intercepts and find the middle of x-intercepts. That's method 1. So somewhere in your notes so far you should have general form, then you have turning point form, and then just underneath turning point form you should have, there are two ways to find turning points. Method 1, find the x-intercepts and you find the middle between the two intercepts. And I've shown you visually, so you can draw the diagram if it helps you remember it. Finding the x-intercepts, find the middle, will tell you the x coordinate of the turning point. Method 2 is a formula. Now you won't know the proof for this formula until you learn calculus, which is at the end of year 11, but for you guys, you might be doing it next year in year 10 enhanced. The formula is this, copy it down. Negative b over 2a. This will tell you the x coordinate of the turning point. So as you're copying that, you should have 3 things so far. In your notes, you should have exercise 7C. You should have the general quadratic form. You should then have the turning point form. Then underneath turning point, there should be 2 methods. 1, find the middle of the x-intercepts. That's how you find the x coordinate. Or use the formula x equals negative b on 2a. So in your notes at the moment, this is what I'm expecting. Okay, so in your notes, I expect title, general form, turning point form. To find turning point, there are 2 ways. So far, you can find the middle of the x-intercepts, or you can use the formula x equals negative b over 2a. What's the b and the a? The b and the a comes from your general form. Okay, so your a comes from the coefficient of x squared, and b comes from the coefficient of x. Okay? But the question is, turning point has 2 things. It has an x and a y coordinate, both of which only tells you x. This only tells you the x coordinate. The middle of the x-intercept only tells the x coordinate. How do you find the y coordinate then? Molly? Well, I think you were on the right track. That is for the y-intercept, but with the same idea though, instead of subbing 0, no, you're finding the intercepts, but instead of subbing 0, you sub the x coordinate in. So, yeah, very good. So you got 3 scenarios there. So, since you've got the general equations y equals ax squared plus bx plus c, if you find the x coordinate, if you want to know what y is, sub it back in. Sub whatever x in to the equation and it will tell you what y is. Okay, and later on I'm going to do a formula for you. If you can't be bothered doing it algebraically, I can show you a formula for it. But right now, I want you to write as a note, how do you find that y coordinate? Say find y by subbing x into general form or turning point form. Okay, because remember you started off with 2 equations. You got general form or you got the turning point form. If you know how to find the x coordinate of the turning point, which is only this value, to find the y value, you just sub it back into either equation. So in the first equation, it will tell you y equals to something. We'll do an example soon. Don't worry. We'll do an example and it'll tie it in. But just for your notes, I want general form, turning point form, so those 2 key forms. I want you to have 2 methods to get the turning point. Okay? And then how do you find the y value? Sub whatever x you found into the equation. Then I'll do an example so you can see. Okay? All right. So far, that's what should be in your notes. Let's do an example. So your example, I want you to copy this equation. Y equals x squared minus 6x. So we're going to try to sketch this graph now. And in order to sketch graphs, there are always 3 things you must have. You have a y-intercept is 1. What's another one? X-intercept, that's your second one. And what's your third one that you must have turning point. 3 key factors. If you don't have one of those, you lose a mark. Okay, the 3 marking system is shape, so you have to have the correct shape. 2, correct axis intercepts, that includes both x and y, and your final one is your turning point. Okay, that's how I mark. I look for those 3 things, and that's how it's marked all the way to year 12. Okay, let's do this example. So hopefully you copy this equation down. You got y equals x squared minus 6x. So let's find the 3 key ones. Number 1, find the y-intercept. Now, back in linear, how do you normally find the y-intercept? What do you have to do, Jaden? Let x equal to 0. So this is when you let certain values equal to 0, and it's only when you're finding x-intercept or y-intercept. For the y-intercept, it's when the x-coordinate is 0 and you're trying to find the y value.
Would you simplify the equation first or leave it?
I do it when I do the x-intercept, but I know what you're trying to say. Yeah. I'm splitting it up so you can see the different methods, what you're actually doing. So for y-intercept, we know that x has to be 0. We don't know what y is, so here's my equation. Y equals x squared minus 6x. You said that to find the y-intercept, x needs to be 0. So here you're substituting x equals 0 into the equation. So this is what I was saying before. Once you find x, you sub it back into the equation. In this case, we're actually looking for y-intercept, so we sub x equals 0. Okay, that's the reason why we sub x equals 0. So if I sub 0 in, y is equal to 0 squared minus 6 times 0. Y is equal to 0. So what does that mean? That means your y-intercept is when x is 0, the y-coordinate, this y-coordinate is 0. That's what you just calculated. Okay, so you subbed in x equals 0, you found y is equal to 0. So you got 1 point now. There you go, got 0, 0. So on the graph, I should have 0, 0. That's my y-intercept. Conveniently, it also happens to be the x-intercept as well. But remember, parabola can end up with 2 possible intercepts because it could have been like this, or it could have been like this. So we don't know yet, or we don't even know whether it's upside down or looks like that. Okay, so there's 4 different possibilities to get a y-intercept there. So we need to then next find, now the second hardest one is the turning point. So I'm doing it in order of difficulty. Y-intercept is the easiest one, then you do your turning point. Now in your notes just now, to find the turning point, there are 2 methods. Method 1, what was method 1? Find x-intercept, right? So we'll do that later. I'm going to use the second formula that I was trying to teach you. The second method was a formula. What's the formula for x-coordinate? X is equal to? Negative b over 2a. Now, looking at our general equation, because that's a general equation, it's not a turning point form. It doesn't have the brackets. It doesn't have the square on it. That's an x squared minus 6x. What is my a, b, and c from this general equation? Let's go with Angelica. What's my a? 1. Very good. It's the coefficient in front of x squared. Even though we don't write it, it's a 1. What is my b? Let's go with Raf. B term. So a was 1 there. So what is my b? B is the coefficient of x.
Where's the equation?
Oh my god.
Ah, it's not there. What?
Wait.
Negative 6. Negative 6. Sorry. I didn't realize you weren't paying attention. My bad. Next one. C. What is the c, which is the constant term? What's c, Nishi? 0. Because you don't see it, so it's 0. So we now use the formula. It's negative b over 2a. So negative b is negative of negative 6 over 2 times a, which is 1. And that gives me now negative is positive. So 6 over 2 is 3. Now this is what I was saying before. This only gives you the x coordinate. So far you now know it's 3, but you still don't know what y is. That's why I said before, I said, well, how do you find this y value? And you don't sub 0 into the equation because we did that already. That was to find the y-intercept. If you want to find the y value, you're substituting x equals 3 into the equation. So here's my equation. Y equals x squared minus 6x. You're replacing the x's with a 3 to find out what y is equal to. So here we go. Y is equal to 3 squared minus 6 times 3. 3 squared is 9 minus 18. And 9 minus 18 is? -9. Very good. So what does that tell me? It tells me now that the turning point is at 3. X is 3. Y is -9. So that's what I mean. That's the 2 steps. So y steps is the easiest. Turning point, if you're using the formula, or even if you're not, you're still just finding the x corner. You have to find the y value as well. So it takes a bit more steps. So turning point takes a bit longer. So now I know turning point is 3. So let's say 3 is somewhere over here. -9, let's say down here. I've got now my second point, sorry. At 3, -9. So in some way, I can already say that it's likely that the graph is going to look like this. Okay, because there's no other way to hit the turning point, but also y-intercept at 0, 0, right? It couldn't have been over here, and it couldn't have been upside down. It's very likely it's going to look like that. But we always want to be clear, so we need to likely find this second x-intercept that's going to occur there. So, how do you find? Now, the third one is the hardest one. That's what you've been training to do. Part 3 is to find the x-intercept. How do you find the x-intercept? What do you do? Sub y equals 0. So in the coordinates, you don't know what x is, but you know the y coordinate is 0. So in the equation, same thing again. Notice that in every single example, I'm using the same equation. X squared minus 6x. The only difference is I'm substituting y equal to 0 now. This is what you did last session. So 0 equals x squared minus 6x, and your job is right here. This is what the mainstream year 10s generally struggle with. From this step, it's your ability to use the algebra you've learned to solve that problem. This is not linear anymore. This is quadratic, and we have to solve what are the possibilities of x. One of the skills that we learned is if you can factorize it, we can then use null factor law. We're saying something times something equals 0. So let's factorize this. How do I factorize x squared minus 6x? Can I please have yes, Raha? Beautiful. They both have a common factor of x. So take out x as a common factor. So it's x times x minus 6. If you like, you can put 2 brackets like that. And I'm saying that number times this number equals 0. So you end up with 2 possibilities. Maybe, according to null factor law, maybe this one's meant to equal to 0. But then that's one possibility. The second possibility is that maybe x minus 6 was meant to equal to 0. But if that's true, then what would x have to be in order for that to be true? 6. So you got now 2 possible x-intercepts. That means 0, 0, and when x is 6, y is 0. So you got 2 x-intercepts there. 0, 0, and 6, 0. I put it together. 6, 0. And now you sketch. Now when you're sketching, couple of pointers. Remember I said there are 3 marks to this? Mark number 1, shape. Number 2, axis intercepts. Number 3, turning point. Right? What's shape? Shape is that when you're drawing it, I don't want to see something like this. Okay, it actually has to show that you've got some sort of curve, right? I also don't want to see this. It's not a sketch. We're not doing that. That implies there are multiple lines in the equation. There aren't multiple lines. It's not an art class. It's mathematics, so you draw one continuous curve. Do it in pencil, do it lightly, and then draw it. But I don't want to see any sketches. If I see that, you lose a mark. Okay? Label the coordinates. Label the turning point. Label your axis intercepts. And that is 3 marks. And not a triangle either. I don't want to see that. No triangles. Because then it's a sharp end. I don't want to see a sharp end. It has to be a curve. It has to be a curve. You have to do a curve. Even if it's slightly wonky here, that's okay. But I don't want to see sketches. I don't want to see that. And I don't want to see that. I need to see an actual just one line, one curve. Okay. A tip is draw the shape before you label the intercepts. If you label it, it's harder to follow the dots. It's easier to draw it first, then label afterwards. Okay, that's how you keep the shapes nice. All right, let's do the next one. Next one. We'll do it a bit faster now. This time I'm going to use this other method, which is the x-intercept method, yeah? Let's go. Let's try this one now.
What's the difference between that method and this?
The... That one?
How you said we're starting with the X.
I'm going to show you how to do it this way, yeah. All right. We're ready? Here we go. Second example. Can you copy this equation down? Y equals x squared minus 8x plus 7. So I gave you a monic trinomial this time. Monic trinomial. So there are 3 terms, but the coefficient in front of x squared is 1. Copy that down. All right. Let's pick out a few students. We need 3 things. 1, y-intercept. How do I find the y-intercept? Can I please have Joanne? What do you do? To find the y-intercept, what do you have to do? Good. You make x equal to 0 to find the y-intercept. So sub x equals to 0. That's what we're trying to say. Okay, so sub x equals 0. So here we go. Write the equation again. Y equals x squared minus 8x plus 7. But hopefully most of you should be able to see what the answer should be if I sub 0 in. What's the y-intercept? 7. Beautiful. So we now have the first point. Like I said, this is the easiest one to find first. 0, 7. So on your graph, you should have 0, 7. Don't label it yet, because I always find it easier to draw the graph first, then label afterwards. Okay, so now you know y-intercept is 0, 7. Part 2, the second hardest one is to find the turning point. Now this time, I'm going to do the other method. Okay, instead of using negative b over 2a, this time I'm going to go to find the x-coordinate. We need the middle of the x-intercepts. Okay, so we need to find the x-intercepts first. So in this case here, we're going from this technique now to find the x-intercept. What do you do? Can I please have Mira? What do you have to do to find the x-intercept? Beautiful. So I don't know what x is, but I know the y-coordinate 0. What this means is sub y equals to 0 into the equation. Okay, so I'm using this new method to find the x-coordinate. Remember you had negative b over 2a, or you can find the middle of the x-intercepts, but we haven't found the x-intercepts yet. So we have to find it now. So to find the x-intercepts, we're going to sub y in. So here's my equation again. Y equals x squared minus 8x plus 7. I'm going to sub y equal to 0. So here's 0 is equal to x squared minus 8x plus 7. And this is what you did last session. So last session, your question is, how do you solve for this scenario? And the best way is whatever method you use, I don't care. You have to be able to factorize it. Anyone want to have a go? Hands up if you know the answer. Yes, Nishi? All right, doesn't matter which way. You could use cross method or grouping method. Regardless, you have to get to this point. If you can factorize, so this here is exercise 5D, 5E. If you haven't practiced that, that's the skill we need. Yeah? Now that we've factorized it using null factor law from our previous lesson, x is equal to what, Michelle? 7 or 1. So this tells me x-intercept is at 7, 0 or 1, 0. But if that's the case, remember, we're still trying to find the turning point, and the method was the middle of the x-intercepts. What is the middle of 1 and 7? Oh my God, is there a quick way to find it? Find the average. If you want to know how to find the middle of it, find the average. So the middle, 1 plus 7 on 2 is 4. Good, but I heard 3s as well. So. That's true, but I just want to make sure everyone knows how to do it. Find the average. Find the average of the two values and then we'll find the middle of the two endpoints. Okay? So it's 4.
What?
All right. Shh, quiet down. Quiet down. All right. So now we know we found the average of the intercepts, and we know that the x-coordinate of the turning point is 4. So I said to you, well, once you find the x, how do you find the y? What do you do, Sanvi? What do you do now that you know the x-coordinate? How do I find the y-coordinate? Very good. In this case, you don't sub 0, you sub x equals 4. Okay, so you sub x equals 4 into the equation. So the other ones you were finding intercept. This one you're not. This one you're finding the turning point. So your equation should then be y is equal to 4 squared minus 8 times 4 plus 7. That's 16 minus 32 plus 7. That's what? Negative 16 plus 7 is negative 9. So that tells me now the turning point is at 4, negative 9. Now remember, like I said, don't label the points on your axes first, otherwise sketching it makes it a bit harder. I'd say visualize where do you think it is. So turning point, you said 4, negative 9, so there's somewhere down here, that's your point. And you know that it has a 1 intercept at 0, 7. So I'm already picturing something like this. It has to be somewhere there because the turning point is at 4, negative 9. 1 intercept is up in the vertical axis above the x-axis over there. So that's how I would sketch. And if you do it that way, your shape looks better. But if you draw in the points, it's much harder to try to maneuver your way to get through there. So as you saw the way I drew it, I'm doing it on a tablet, by the way. It's not even on paper. And it looks fairly good. So imagine when you're doing it on paper, it's much better. Yeah, so draw the graph first, estimate roughly where it is, then label it. Yeah, so if I were to do it, I would have just done like that. Okay, so I would have drawn the shape. One quick stroke, something like that. Label the intercepts, and now I can then say 0, 7, 1, 0, 7, 0, and turning point 4, negative 9. Label your x and y axis, y, x. That's a perfect 3 marker. Okay, so again, I don't want to see those random sketches. I don't want to see a triangle, and I don't want to see like some weird parabolic shape. Okay, so draw the shape first, then label the coordinates is usually my sort of advice when you're trying to get the shape right. Okay? All right, team. I'm going to leave the last example for you to try. It's just on the bottom there, x squared plus 8x plus 16. And that's today's lesson. Now, before I stop the video,